In this video lecture, we will be solving questions on pre-finals, general science, that is paper 1 physical science question paper. The question paper is very easy and two questions from practice paper are repeated in pre-final examination. So my suggestion to you all is to practice all the practice papers and pre-final questions well for your board exams so that you may pass with good marks. First question deals with activity series. And it is asking us why metals at the bottom do not react. So activity series consists of three parts: high reactive, middle reactive and low reactive metals. So here it is asking that why metals at bottom of the activity series do not react with others. The metals like silver, gold and copper are available in nature in free state as they are least reactive. So they do not take part in chemical reactions. That is, they are available in free state, that is, they do not combine with other, they are not available in combined form, and also as they are not available in combined form, they are available in free state, they do not react with other metals. Guess and write why does overload of electric current cause damage to electrical applications. So what is the answer for this? The minimum and maximum limit of current that can be drawn from the mains is 5 to 20 amperes. When the current drawn from the mains is more than 20 amperes, overheating occurs and may cause fire and thus damage electrical appliances. Here the minimum limit is 5 amperes and maximum limit is 20 amperes, and because of overheating, electrical appliances may damage when the current exceeds 20 amperes. Draw the figures and label for myopia defect vision of eyeball and hypermetropia defect vision of eyeball. Myopia and hypermetropia. The answer is, for myopia, it's asking defect of vision. Defect of vision means I have to draw only figure 5A and figure 5B. In figure 5A, we can see the rays are parallel. We have a point M that is called as far point here, and L that is point of least distance of distinct vision here, and the image is formed before retina here, right, as you can see. And we have to draw figure B. Here also we see that the object is before M point and we have L point, and here also we have rays meet before the retina. So that is why you just have to draw two figures, figure 5 and figure 5B, for this answer for myopia, and you have to write where M is called as far point and L is called as point of least distance of distinct vision, because here it told us to label the diagrams, and also below it you should write myopia defect of vision. Okay, next coming to hypermetropia. Metropia also image is not formed on the retina, it is formed beyond the retina, as you can see here. Here also we have 2 points, point H which is called as near point in case of hypermetropia, and point L which is called as point of least distance of distinct vision. So here you just have to draw figure 6A. Okay, the rays are, when they are in between H and L, then image is formed beyond the retina, right? Write the applications of semiconductors in daily life situations. Daily life situations means day-to-day activities. You have to write the uses of semiconductors. So we can write the applications of semiconductors in day-to-day life are mobile phones, watches, cameras, televisions, LED bulbs, etc. Draw the figure and label for froth flotation process in metallurgy. This is an important question and was also asked in previous practice paper. So we can write for this the answer: froth flotation process. For the concentration of sulfide ores, there is a beaker and we have a pipe through which compressed air is passed. Okay, and then we have to the compressed air pipe is attached, we have water containing pine oil, we have sulfide ore particles, ganj that is impurities, froth bubbles carrying sulfide ore particles. So you also have to do naming, all the 5 namings here, labeling compressed air, sulfide ore particles and froth, water, ganj, all this you have to also write, remember it, diagram as well as labeling. So you have to practice this diagram well. Explain the limitations of Bohr's model of hydrogen atom. Limitations means drawbacks or disadvantages. So you know in structure of atom, Bohr's model of hydrogen atom we have studied. So what are the drawbacks? It failed to account for splitting of line spectra, that is We could not split the line spectra in case of Bohr's model, and it did not explain Zeeman and Stark effects. Now section 2, question 7. Guess and write what happens to light rays when transparent material with two curved surfaces is placed in its path. So we have to write what happens to light rays. That is, when light rays are coming and when they hit a curved surface which is consisting of two curved paths, two curved surfaces, okay, then what happens? This light is hitting the curved surface, and after that what happens, that we have to see. See, this is my lens, right, which is there, two curved surfaces. Now the light rays are coming, they are hitting, and what happens on the right hand side after they hit? So what happens to light rays? Remember, whenever light rays hit the transparent material, refraction occurs. So you also have to write the same thing. When light rays hit the transparent material with curved surfaces, refraction occurs, and then you have to draw two diagrams consisting of convex lens and concave lens. You can see the first diagram is a figure. If that you have to draw, you have F1, C1, F2, C2 and a lens. Light rays are coming, and then whenever light rays are parallel, what happens? They undergo refraction and they meet at the focus. That you have to draw. That is for convex lens. Then see, you can see, right? Next you have figure 5b, in which we have concave lens. Here also light rays are parallel, but they appear to meet, okay, and here also refraction occurs, okay. They tend to either bend away or bend forth. So here both the cases are there, convex and concave. You have to draw these two figures. These are available in textbook also, okay. Next question is question number 8. The following table is based on defects of vision in eyeball. For 3 things are given to us: defect of vision, myopia, double concave lens; hypermetropia, double convex lens; presbyopia, bifocal lens. Questions first. Write the name of the defect of vision. A person cannot see objects at long distances but can see nearby objects clearly, and write the name of lens to rectify defect of vision. So here, name of defect of vision of a person who cannot see nearby or long distances clearly, and short distances he can see clearly. That is called as myopia. Long distances cannot see clearly. And it is also asking what is the rectification for this defect of vision. Rectification means how can we solve that problem. So myopia, as we can see in the table, it can be solved with the help of double concave lens. So you should write the rectification for this is double concave lens. Second bit is you have to name the defect of vision. A person finds it difficult to see nearby objects clearly and distinctly, and you also have to write name of the lens to rectify defect of vision. Again, 2 parts are asked here. So you should write the name of the defect of vision. A person cannot see nearby objects clearly is hypermetropia, and the defect of vision to correct and the lens required to correct this defect of vision is concave double convex lens. You have to write that. Next, 9th question is aim of the experiment is to show that the ratio V by I is constant for a current carrying conductor. You have to write list of materials required and steps of procedure. 2 things are asked, okay. Underline those questions, like whatever is asked in the exam. Those questions, if you underline, you will remember how to attempt that question. So here, this is also an activity from the chapter electric current, okay. The answer for it is to show that the ratio V by I is constant for a conductor. Materials required. Before seeing materials required, you can see you have to draw this figure also. In the figure, you have a battery, an ammeter, a key, an iron spoke, okay. So what is required? You require 5 dry cells of 1.5 volt each, and those dry cells, when we combine cells, we know a battery is formed, right? Then we require conducting wires for connecting, and then we require an ammeter for measuring current, voltmeter for measuring voltage, and an iron spoke, okay. What is iron spoke here? Iron spoke is this, okay. And we need an LED. LED is used for glowing, and a key to switch on or switch off. So what is the procedure? Here we are going to connect. Always write this procedure in points. So the first point is connect a circuit as shown in figure, and solder the connecting wires to the ends of the iron spoke. Solder means we are going to burn it and we are going to close it. Then second point is close the key. Third point is note the readings of current from ammeter and potential difference from voltmeter. That is, from ammeter you will get the value of current I, and from voltmeter you will get the value of voltage V. That we are going to make an observation table, serial number, potential difference V, current I, and R is equals to V by I, and we are going to note all these values in that table. Okay, what is V by I here? V by I is R, and just you can leave this table as it is after drawing. Means you should not fill that table, but you should draw this table and name it as 1, 2, 3. For example, for first case, what is the voltage, what is the current, like that. Now these 3 points already we have written, right? From fourth point we have to write. Next point you'll write is, now connect two cells in the circuit and note the respective readings of ammeter and voltmeter in the above table. Repeat the above procedure using 3 cells and 4 cells and 5 cells respectively. At first you're going to use 1 cell, then you're going to perform the experiment for 2 cells, then 3 cells, then 4 cells, then 5 cells, and then correspondingly you're going to record values of potential difference V and current I, okay, in the above table. Find out V by I for each of these values, and we notice that V by I is a constant. Constant means it is a fixed value, so we can say V directly proportional to I, and potential difference between the ends of the iron spoke is directly proportional to current passing through it. This is called as Ohm's law. Now 10th question, draw the ray diagrams for 3 situations to concave mirror. First is when incident ray parallel to principal axis. So remember, this is my concave mirror in which I have pole P, focus F, and center of curvature C. So it is telling me that a ray is parallel to principal axis. Okay, so let us suppose there is an object O. From that object O, a ray is parallel to the principal axis. This is called as principal axis on a line on which P, F, and C is there. Whenever a line is parallel to principal axis, it passes through focus. Okay, so we have drawn that diagram. Next is second bit, incident ray passing through focus. Passing through focus is opposite of the first rule. That is, whenever a ray is passing through focus, okay, what happens? It will be parallel to principal axis. And one more thing, the distance between P and F should be equal to F and C. For example, if you are taking distance between P and F as 2 cm, take the distance between F and C also as 2 cm. So a ray passing through focus is parallel to principal axis whenever an object O is placed. C, passing through focus parallel to principal axis. Okay, next is question number third bit, that is what happens when an incident ray passing through center of curvature. So again you have pole P, F focus, and center of curvature C of concave mirror. So here the ray is passing through center of curvature. So remember, whenever a ray passes through center of curvature, see here since I am drawing it approximately, it's not coming as a straight line. In exam you have to use a scale and draw that diagram with scale. Okay, so whenever a ray passes through center of curvature, it goes back along the same path when an object O is placed. I'll explain this diagram again. See, you have P, F, and C, that is pole, focus, and center of curvature. An object is there. From the object, a ray is passing through center of curvature. You have to show the arrow. What happens? It goes back in the same path through that center of curvature only. That is the third bit. See, the questions are so simple. You can see. Next question is question number 11. So here you have to draw the diagram like whatever you have to draw that. Here you have a beaker. Okay, you have in that beaker you have two graphite rods, iron graphite rods. Okay, and to that iron graphite rods we have some dilute sulfuric acid, and to that iron graphite rods we have iron this socket connected. Okay, remaining things also, okay, as shown in the screen. Then we have materials required: AC plug, 230 volt bulb, bulb beaker, dilute HCl solution, alcohol solution, glucose, and dilute sulfuric acid. See, because we have 4 cases here: dilute HCl solution, alcohol, glucose, and dilute sulfuric acid. So you have to write all the materials whichever are used to perform this experiment. Right. Next you have procedure. So prepare glucose, alcohol, hydrochloric, and sulfuric acid solutions. You are going to fix 2 iron graphite rods on a rubber cork. Rubber cork is used to fix the iron graphite rods firmly inside that solution. Okay, and it consists of a 100 ml beaker. we are going to connect two different colored electrical wires to graphite rod separately as shown in figure, right? And then we are going to connect the free ends of the wire to a 230 volt AC plug. Complete the circuit as shown in figure by connecting a bulb to one of the wires. Now pour some dilute HCl in the beaker and switch on the current. Observations: we observe that the bulb starts glowing. The repetition is we have to repeat the activity with dilute sulfuric acid, glucose and alcohol solutions separately. Then you have to write an observation. We observe that with dilute sulfuric acid and dilute HCl solution, the bulb glows because of presence of H plus ions, and you should write with glucose and alcohol, the bulb does not glow as it consists of OH minus ion solution. Therefore, we can say all compounds containing hydrogen are not acids. Write the skeleton chemical equation and balanced chemical equation for iron oxide reacts with aluminium to form iron and aluminium trioxide. So you have to write skeleton chemical equation. Skeleton chemical equation means unbalanced chemical equation, and also you need to show balancing here in this answer because it is an 8-mark question. So we will write skeleton chemical equation and then we'll balance. How to balance? We know iron oxide is Fe2O3 plus aluminium is Al, iron is Fe and aluminium trioxide is Al2O3. So we will write Fe2O3 plus Al giving rise to Fe plus Al2O3. That is what it told that we are writing. Iron plus aluminium giving rise to iron plus aluminium trioxide. Now, how to write the balanced chemical equation? How to write the balanced chemical equation? Write down element, number of atoms, LHS, RHS, whatever elements are there, you should write that in the LHS column. That is FeO and Al. And how many atoms are there on the LHS for iron? 2, and for oxygen 3, and RHS 3. Aluminium, oxygen, aluminium. How many atoms are there? 1 atom. We can see. Then 2 atoms at the bottom for aluminium on RHS. So that we have to write. Remember, the atoms which are attached, they are there naturally. Naturally means we cannot attach the atoms by our wish. Only we can write the atoms beside, not below. So here if we observe, the atoms of iron on LHS and RHS are not equal, 2 and 1. Similarly, atoms of aluminium are also not equal on LHS, 1 and 2. So what to do? Either balance iron or either balance aluminium. So what we will do? We will balance iron first. Okay, so how to balance? Here we can see that number of atoms on LHS are 2. So make the number of atoms on RHS also as 2. How to make the number of atoms of RHS on 2? We can multiply this 1 with 2, so it becomes 2, because we know 1 2s are 2. So we are going to make a change of 2 iron atoms on RHS of the chemical reaction. So the only change here is after we add 2, that is after we multiply 2 on the RHS, the equation becomes Fe2O3 plus Al giving rise to 2Fe plus Al2O3. See, 2Fe, because we are adding 2 iron atoms on the beside, okay, because we are multiplying with 2. You can see here, that is the only change we made in this chemical reaction. Now what we should do? Similarly, multiply 2 on the LHS of aluminium atoms, so that number of atoms on aluminium also becomes equal to 2, because we know then only it will be balanced. So next again make the same table. Element, number of atoms, LHS, RHS, Fe, 2 atoms on LHS, 2 atoms on RHS, O, 3 atoms on LHS, 3 atoms on RHS. This we are writing from the chemical equation, right? See here we can see, right, here the atoms are there, all are balanced, only aluminium. Here on RHS we have 2, so on LHS also we can multiply with 2. It has only 1 atom. So multiply aluminium with 2 atoms, okay, so that it becomes 2. So 1 into 2 is 2. Now all the atoms are balanced. You can see iron, oxygen, aluminium, 2 2, 3 3 and 2 2. So what to do? Multiply 2 on the LHS of aluminium here. So the balanced chemical equation becomes Fe2O3 plus 2Al giving rise to 2Fe plus Al2O3, okay. There's a problem in recording here. So actually the question was Muller's orbital was given to you, 1s, 2s, 3s, 4s, as you can see in the on the screen, and you can see in your question paper of physics. So in that question it asked, write the 2 general rules which help us to predict electronic configuration. So we have the answer in the textbook. Two general rules help us to predict electronic configuration. It is there at the bottom of the textbook, the 2 points in Aufbau principle. First point is electrons are assigned to orbitals in order of increasing value of n plus L. And second point is for subshells with the same n plus L value, electrons are assigned first to the subshell with lower n value. Second bit is write the ascending order of elements for various atomic orbitals. Ascending order means small to big, means whatever is shown to you in the diagram, first you should write like that: 1s less than 2s less than 2p less than 3s and so on. The arrows are shown, that you have to see and write. Okay, see, I'll write and show you again. 1s less than 2s less than 2p less than 3s less than 3p less than 4s less than 3d less than 4p less than 5s less than 4d less than 5p less than 6s less than 4f less than 5d less than 6p less than 7s less than A5f less than 6d less than 7p less than 8s. This I have written the ascending order of energy orbitals with the help of arrows only, as you can see here. First 1s, then 2s, then 2p, then 3s, then 3p. Like that order you have to follow. Okay, be very careful when writing. Okay, don't reverse the order. Okay, whenever you write. Third bit is we have to write about the electronic configuration of argon. So argon also, it gave the atomic number of argon is 18. So how will you write? You will write 1s2, okay, because by seeing this Muller's orbital only, and the number of electrons you can see at the top, that we have to add, and when we add those number of electrons on the top, we should get as 18. So if we write 1s2, 2s2, 2p6, 3s2, 3p6, we are getting 18. See, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18. And one more thing I want to say you that whenever you write the electronic configuration, remember that the maximum number of electrons on S can only be 2 and maximum number of electrons on P can only be 6. It should not be more than 6 on P. Similarly, it should not be more than 2 on S. You already know this, right? It can be 3, 4, 5, but it cannot be more than 6. Okay. So next fourth bit is write the relation between N and L. So the formula for relation between N and L is equals to 0 to N minus 1. That is the relation between L and N minus 1. The last question is explain groups and periods in the modern periodic table. So already this question also came in practice paper. The same answer you can write for it. Modern periodic table, groups and periods. So what is the answer? We can write elements are arranged in increasing order of atomic numbers. Elements in the modern periodic table are arranged in 7 periods and 18 groups. Horizontal rows are called periods and vertical columns are called as groups. Elements are placed in periods based on electronic configuration of atom. Then the periodic table explains similarities and variations in properties of elements, and it brings clearly the trends in chemical properties across long periods. All these points you have to read, understand, and then write in your own words. No need to use the exact words. Then inert gases having completely filled electron shells have been placed at the end of each period. Such a location of the inert gases represents logical completion of each period. The great advantage of this periodic table is that it can be divided into 4 blocks: S block, P block, D block and F block, and we can give a clear transition between metals, transition metals, semiconductors and non-metals. And due to separation of the two subgroups, dissimilar elements, example alkaline metals and coinage elements, the metals, they don't fall together.